Right, we are continuing to talk about our introduction into linear equations. And there are three different forms that you're going to have to be aware of that you're going to be tested on the end of the course exam that you're going to be taking at the end of the year. So the very most basic form is what's called Slope-Intercept Form. Okay? And if you guys look at the word Slope-Intercept Form, it has two words in it. It has the word slope and it has the word intercept. The m value right here in this form represents the slope of the line. The b value right here represents what is called the y-intercept. Okay? So you can write that down. So right now, if we look right now, our m value, which is our slope. And what does slope equal? It equals the rise over the run, which means, what's a quick review? The change in the y over the change in the x. And there's our slope formula. Here's our slope formula right down here. Okay? y2 minus y1 over x2 minus x1. So right now, if we were to look at this, I'm going to highlight it right here in orange. M represents slope. What's our m value in this particular equation right here? What do you guys think? That's it, negative 2.5. So right now, for this particular problem, our slope is given to us. It's negative 2.5. Now that can also be rewritten as an improper fraction. All right, we put 4. It's easier to graph like this. Negative 5 over 2. So that would be the slope as an improper fraction. And what I'm going to do right now, really quickly, all right, for the video here, I'm going to graph this line right here on some graph paper, okay? I'm going to go ahead and graph this line so you guys know, see what it looks like. So I'm going to right now, I'm going to make a x-axis and I'm going to make a y-axis right there. And let me see here, I might have to make it a little bit higher up. Yeah. I'll explain why. All right, and what was our equation in slope-intercept form? Negative 2.5x, and was it a minus 3 or plus 3? I'll go back. Oh, minus 3. Okay, minus 3. Now I could write it like this as well. You might see it like this: negative 5 over 2x minus 3. Now remember, we said our slope was negative 5 over 2. And we said our y-intercept was a negative 3. So watch right now. I'm going to plot my y-intercept first. I'm going to go down. 1, 2, 3. Put a point. And that's my y-intercept. Why do we call that the y-intercept at 0, negative 3? Because that's where the line touches the y-axis, or crosses the y-axis. Now from here, what's my slope? I'm going to go down 5, and I'm going to go over 2. So I'm going to go down. 1, 2, 3, 4, 5. I'm going to go over 1, 2, right there. And we're going to eventually be making these lines, okay, and graphing them over and over and over again to get good practice. But this is the line. Y equals negative 2.5x minus 3. It goes down 5 units and over 2 units. So I'm going to highlight the slope right now. It goes down 5 and over 2. So you guys should see like a triangle being made. See if you guys can recognize this. It goes down 5 and it goes over 2. What do we call the negative 5? We call that's the rise. It goes down. What do we call this section right here? That's the run. It goes over 2. So that's the down 5 over 2. So we're not going to graph every single one of these, but I want you guys to see what that graph looked like for this problem right here. Point slope form has 2 words. It has the word point, it has the word slope. What letter always represents slope? What letter? N. Look right there. What's our m value in this? Yeah, that's your slope. So in point slope form, right now I'm going to say, what's my m value in this problem? My m value is what? Negative 1/3. Now we're gonna later on. I'm not going to tell you everything there is to know about point slope form right now. We're going to be doing that later on. Okay? Right now, what's this whole topic we're talking about right now? Just slope. Okay? So that's your slope. Now, what does a negative 1/3 slope look like? It goes down 1 unit, right? Down -1, and it goes to the right 3 units. That's what a negative 1/3 slope looks like. Now, this is the part where we get in. It's a little bit tricky. It says standard form. All right? Do you guys see any m values in standard form? No. So what we have to do, everybody, in this form, we actually have to solve for y. Now, I know some of you know the shortcut for finding slope of standard form. I'll get to the shortcut, so don't hate on me just yet. Okay, I know shortcut. Yes, I know n is equal to negative a over b. We're going to get to that shortcut later. Okay. Now, if we're solving for y, what am I going to have to do to both sides? I'm solving for y. What do I got to do? Yeah, -4 what? X on this side and what? -4x on this side. So what are we dropping down here? Dropping to -5y. So that's what you're writing in your journal right now. If you're a dependable and responsible student, you're writing this down in your journal. Practicing solving for y. So what did I do with the -4x? I moved it up front. What did I do with the 15? Moved it on in the back. Okay, I just paused the video now. I'm starting again. Right now, we're solving for what letter? We're solving for y, right? So right now, I have a -5 times y. So what am I going to have to divide every single number by? -5. No, not -5y, just -5. So I divide this by -5. And I divide this by a -5. Now, a -5 divided by a -5. It's a beautiful thing that happens. Cancel out to a positive 1. Alright, because a negative divided by a negative is a positive. Alright, so we're just left with one more. Now, a negative divided by a negative is still a positive, but 4 is not divisible by 5, so we just leave it as what? 4 over 5. And then here it says 15 divided by -5. And 15 divided by 5 is 3, so 15 divided by -5 is a -3. Hey, what form does it look like this is now in? Hold on. Does it look like it's in point slope form, or does it look like it's in slope-intercept form? You're right, it is slope-intercept form. So right now, what have I done? I've changed it from standard form to what form? That's right. It's something you guys need to know how to do. By the way, this is the only day we're going to practice this? No. We're going to practice this a lot. So right now, what would my slope be now? What would you guys say my slope is? Yes, right there. Look. Because in slope-intercept form it says what? Y equals mx plus b. And this is y equals mx plus b. Now what's my y-intercept? At a -3. But my slope is at 4 over 5. Now what does that mean? It means it goes up 4 and it goes over to 5 units. So that's your slope. Now, did you guys see I did a little shortcut here? A little shortcut, didn't I? That's what I was doing. Ooh, here's a shortcut. Now, what did I say? This in standard. This only works in standard form, everybody. And it has to be in standard form in order for the shortcut to work. What did I say it was? It was -a over b. Okay, so what is my a value? What do you think my a value is? 4. So what would -a be? If I say negative and I plug in a 4, what's that going to be? Become a? Now, hold on, that's a -4. What's my b value equal to? More specifically, -5. So my b value is a -5. So what's -4 divided by -5? 4 over?
I was already there.
So you were just speeding it up. You were already canceling out the what? Canceling out the negatives. Okay? So by the way, would you guys like to do a quick little standard form shortcut? So you guys know how to do it? Sounds like a plan. Here we go. Ready? Here's an equation in standard form. 2x minus 4y equals 12. A, B, C. What's my A value? 2. What's my B value? Nope. Minus 4. And what's my C value? 12. Okay. So everybody, remember, standard form is this. AX plus BY equals C. So right now, what did I say your m value, which is your slope? What's slope always equal to? -a over b. So what is my negative a value? What would my negative a value be? Negative 2. Because if a is 2, then negative a would be negative 2. What's my b value equal? Negative 4. Ooh, a negative divided by a negative is a positive, but 2/4 can be reduced to 1/2. So your slope of this line would be 1/2. Okay, one more. Here we go. 2x plus 3y equals 5. What's my a value? 2. Okay. What's my b value? Hold on. Here we go. B value is 3. What's my c value? 5. So I said slope is equal to the negative a value over the b value. What is my negative a value? Negative 2. What is my b value? 3. Your answer would be, hold on, let me make it negative 2 over 3. Ah! There we go. So my slope would be negative 2/3 in this particular case. Okay? You guys see that? 2x plus 3y equals 5? Check it out. If I type in 2x plus 3y equals a 5. Okay? What did I say the slope was? Negative 2 what? Negative 2/3, right? So it would go down 2 and it would go over 3. It would go down 2 and over 3. That's what slope is. Okay? You guys see that? How it goes down 2 over 3, down 2 over 3. That's what's called a constant rate of change. It constantly goes down. It's down 2 and over 3. What was our other, let me go back to our other example here. It was 2x minus 4y equals 12. I'm going to type that one in really quick, okay? Oh, not there. Here. I'm going to delete this. What was it? Was it 2x minus 4y? 4y equals 12. Now, what did I say this slope was? Remember what I said the slope was? No. Go back. What was it equal to? 1/2 of 1 over 2. Of 1 over 2. You guys see the pattern? That's how you can interpret slope. I loved interpreting slope on graphs because I could always find how much it went up and how much it went over. Now, here's where you have to interpret slope. The points have to be perfectly in the crosshairs. You guys know what crosshairs are? Like, you guys ever play those like first-person shooter games where you're like the sniper? All right? Yeah, like the scope. Exactly. What do they have? Actually, that point's not perfectly on there. Ah! But it's got to be perfectly in the crosshairs. So notice, I have to put the point here. I can't put the point right there because that's not perfectly where? On an ordered pair. You have to have a perfect ordered pair in order to interpret the slope where it goes up 1 and over 2. Right. Do I know exactly where this point is right there? Do I? By looking at it? No, I can't. So that's where you have to use your logic when you're interpreting the slope. Okay. We've done a lot of work. Right now, we need to go down. You guys have to prove to me that you know how to find the slope of the line. So all I'm going to do right now is you're going to do B right here. You're going to first label this. You're going to label this x1, and you're going to label it y1. And you're going to label this x2, and you're going to label this y2. And you're going to use this formula right here. And you're going to do it on your paper right now. If you're watching this video, you're going to pause it, and you're going to do it. And you're going to check to see if you got it right. There we go. I'm going to label y2 minus y1 over x2 minus x1. Go ahead. Make it happen. I made a mistake. Here we go. Put y2. Now pause it. Hopefully you didn't pause the video before it was too late. I made a mistake. Thank you for pointing that out. X1, y1, x2, y2. Did I say y2 and just wrote down y1?
You said y2.
But I wrote down y1. Okay, there we go. So make sure you take these ordered pairs, and what are you going to do with them? You're going to plug them into the formula correctly. Make sure they go in the right place. All right. In order to do this right, you need to organize your information. Okay, so the first thing you should have done, where it said y2, you should scan over here. What did we label y2 as? 1. So you put a 1. What did I label y1 as? 5. So I put a 5. Then over here it says x2 minus x1. So what did I label as x2? So you write in a negative 3. And then x1 is a, so you write in a 7. Okay, now, I'm going to do this by hand, and then I'm going to show you how to do it in the calculator. All right? So we have 1 minus a 5. 1 minus 5 is a negative 4. Negative 3 minus 7 is a negative 10. A negative divided by a negative is a positive. But 4/10 can be reduced because 4 and 10 are both divisible by what number? 2. And what's 4 divided by 2? 2. What's 10 divided by 2? 5. So the answer is 2/5. So that's by hand. Okay? What we're going to do now is we're going to use a graphing calculator. We're going to do the exact same thing. So check it out. We're going to go out the y equals enter. I'm going to open up a parentheses. I'm going to type in a 1. I'm going to close it. Minus. Open parentheses, type in a 5, close it. Go down. Open parentheses, type in a negative 3, close it. Wait, negative 3 is a negative 7. Okay, good. Okay, I'm just going exactly what I did. All right. By the way, if you organize it, if you sorry, not negative 7. There you go. Careful. By the way, what am I trying to show you right here? If you organize it just like you did it right here, then you'll get it right. But all you have to do is organize. Look what the calculator does for you. I'm going to press enter. Don't even have to do the math enter thing, do you? It's already what? Done. Completed. Simplified. What does this represent? Y2. What does this represent? Y1. What does this represent? X2 and X1. Do parentheses matter? Yes, they do matter. All right? But if you can remember how to do that, you can get all of these questions right if you just organize the information. Okay? So, right now, if we go back to our problem, it says, explain how the rate of change is related to the slope. Here's what I want you guys to understand. I'm going to write this down, see if it makes sense. Read me that statement, Tristan. Read me that statement right there.
Explain how the rate of change
Okay. Dalton, read that for me.
rate of change equals
What do we think I'm trying to say with that statement? It's the same thing. The rate of change is the slope. All right? Slope has a constant rate of change. If we look at over our graphs, see if we can find something. What was the rate of change? What did it do? It went down 2 over 3, down 2 over 3, down 2 over 3. Did that change at all? No. It stayed the same. That's why they call it a constant rate of change. Okay? So, right now, what was the slope of this one? It went down 5 and over 2. That was its constant rate of change. So that's what you need to understand. How are they related? The slope is the rate of change. That's how they're related. Okay. Last part, right here. It says, for each interval shown in the graph, calculate the what? Rate of change. So right now, I'm going to give you guys hints. Right now, you're going to have to calculate this, okay? So see if you can interpret what I'm doing. Starting right here. 1. You guys see all these little points right here I'm doing in red? Okay, here's what I want you to do on your paper. I want you to make stairs. Make stairs. Like this. By making the stairs, it's helping reinforce what the slope actually is. Now, I'm going to call on one person who kind of gave it away at the very beginning. I'm not going to name any names, Tristan. Could you tell me what you were telling me to do? It says what? You said it was 1 over 1. What does that mean? Up 1? Do you see how it stays the same? That means the slope is constant. It's a constant rate of change. It is going up 1 and over 1. What's 1 over 1 equal? 1. That means in interval number 1, the slope is 1. Okay? Now, I'm going to change colors here. Going green. Got a point right here. 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 So, right now, I'm going to go up nothing. Over 1. Up nothing. Over 1. Up nothing. Over 1. Up nothing. Over 1. So how much should I go up? 0. How much should I move to the right? 1. What's 0 over 1 equal to? 0. That's why this is a slope of 0. Changing colors. We've got a point right here. Got a point right here. And right here. Up. Here. Got here and here. How much do I have to go up? How much over? Ooh. Up. Over. Up. Up. Best video ever! Alright. That was all. We can do that. That was awesome. Hold on. It was like almost like a song was about to start. You know? That's right. Hey. Alright. So what was how much did it go up? It went up what? 2 over 1. What's 2 divided by 1? No. 2. That's right. Don't worry. It's not gonna be on YouTube forever. Right? Ooh. Last but not least. Here's a point. There's a point. There's a point. There's a point. There's a point. How much do I go down?
1.
No. 2. Over. Down. Over. Down. Over. Down. Over. Alright, how much did I go down?
2.
Alright, I went down. That's negative 2. How much did I go over? 1. What's negative 2 divided by 1? Negative 2. That slope is a negative 2 slope. So look, positive what does what? It goes up from left to right. Okay? 0 slope does not go up nor down. By the way, can you walk on this slope? Can you walk on this slope? Can you walk on this slope? Yes, it'd be kind of tough, okay? Can you slide down that slope? Yes. And you always re-slope from left to right. Good job. You're now done.